All right, time for another coding session with Bangalang, and we're continuing with our refactor. We started last session to refactor and create a more solid concept of scopes. We came across some issues at the end, which I found the solution to. Well, I got Claude to figure it out for me, but we'll go through it together. Before I did turn to Claude, I just went through all the changes I made to see if I could find the issue. And I didn't find it, but I did find some other things that I would like to clean up, just a couple of things. So the first one is this get identifier node. I'm going to rename this to get declaration at some point, I think, because that's a bit clearer. That's what it's, for a certain identifier, it's going to get the declaration for that identifier. So this part here is, I think it searches for a module. So this is, if it's something that's imported, this is grabbing it from the other module where it's imported from. Otherwise, we want to look at the current context identifiers and also the out of order identifiers in that context. And then we want to move up the scope tree all the way to the root. Yeah. So that's what this loop does. It starts with the full path and it moves up, but it makes sure that the length is always greater than 1. So it's going to move up, I guess, to the module level with that current condition. Now, it used to be that procedures were all this, this was looking through procedures specifically, and then we have this separate check here to look in the module and another separate check to look in the program level. But now that it's all just a tree of scopes, what I can do is just say greater than or equal to 0 in the path length. So that's going to walk all the way up the tree to the root now, because it's going to go up to, the last iteration of this loop will be where the path is empty, which is the root, which means that we don't actually need these separate checks. It's all handled in here. So I think we kind of need to change this. I'll just call it current, because it's not always a procedure. So I just wanted to do that little bit of cleanup. That's a much more simplified. It's still a fairly complex procedure, but at least it's simpler now. So that takes care of that one that I found. In the main file, because I renamed this package from program to loading, I guess CLion in its wisdom decided to change this to loading, build and run the program. This is the printout when you're using the CLI, and also here. So that was just a little random thing. And when I was playing around at the end of the last session, we commented out a bunch of tests. And I want to uncomment them, so we're running all the tests again. Like so. Okay, looks like it's all uncommented, and then this part down here. There we go. Okay, so now that should run all the tests when we do the health check. So that's that one. And now this is the crux of it. This was the actual issue that we were seeing. So when I do like the health check, we should see the issue. I don't get a segmentation fault. It depends, different runs could have different errors. Well, it's always giving segmentation fault now. That's interesting. Actually, this is a separate issue. That seems to come up with the changes. So when we're type checking, and we add whenever we reference a procedure, we add it to the queue of procedures to be type checked. And because it could be added to the queue multiple times, we have this type checked flag that we set once we're done type checking it. And then if the same procedure comes along in the loop, then we say, okay, it's already type checked, nothing to do. In this case, the procedure is null. And I believe if we look at the path for the procedure, it has length 1 and it's import. So it's the import procedure from the globals module. And the reason that the procedure is null is because import does not have a procedure body. If we go to core globals, these 3 procedures that are listed here, they all have an allocator of none. That you can see there's no procedure body here, and it's not that they're referring to some external procedure and some other lib or anything. They just don't exist. You know, import is just, it's just something for the compiler to know that we're importing this other file. It's not something that actually needs to be output or type checked. So in the case where the procedure doesn't exist, whoops, I need to fix up I always do this. That one. So I think we can just do that, and we can say, you know, if the procedure doesn't exist, there's nothing to type check, and that's fine. So we continue, I think. Let's get rid of that. So this is the error that I was expecting. Yeah, lots of these asserts has not been defined. So the fix for this, I found out, was at the moment our tree of scopes, each child in the tree is you know, it's a map of string to scope, which means that the scope object itself is embedded into the map. But that's not a stable reference. You know, if you take a pointer to one of these scopes, it's not a stable reference because the map, as you put more things into the map may need to reallocate and point to a new chunk of memory, which means that the old scope that you were pointing at is garbage now. So in the best case, you write to it and that memory has not been allocated for anything else yet, so your writes are effectively just lost. And in the worst case, that memory was reallocated and now you're corrupting that memory by writing to it. So to solve all of that, I'm going to go like this. This is the fix. So now they are just pointers. So when I grab them out of the map, the scope itself is stored somewhere else in memory. It means there's potentially more memory fragmentation, you could say, but it solves the problem. And we'll worry about memory layout later when we get to performance. So now there's going to be a bunch of errors because it's not expecting that to be a pointer. There's actually not too many errors. So let's start from the top. So this is when we are loading a module. So I think we're checking if the library exists, and if it does not, we need to create one. So now we need to create it with the new keyword. So we heap allocate it, assign a path to it, and then add that new lib into there, into the program. And now we can say that, yeah, so we grab that lib out. And we need to assign a module to it. So let's go new, ast.scope. Whoa. Add a path which is the full path we passed into here, like we did before, and then the statements is the nodes. So it's exactly the same, we're just constructing it from a pointer now, and then we assign. Cool. So that takes care of that. And here we have a procedure which I think we stack allocate. So now we want to heap allocate it. Oh, that's right. It needs to make an assignment. So that takes care of that. Type checking a call. This concrete procedure. We also want that to be allocated with new. That takes care of that. I think we can get rid of that and that. Don't really need these open anymore. And then this util, it's already a pointer, so we don't need to take the address of it. Like so. I think that's all the errors. Now it's trying to link import, which tells me because we have this sort of references thing, these references on a scope, which it's a little bit funny, I guess. It's a little bit overloaded. So references on the root of the tree, which is the program, they represent links, things that need to be linked with it. And import is being added there. So where is that being handled actually? I guess there should be some special code that looks for, the link procedure. So this is in the x86 generation. When it's generating a link. And something I was thinking of before, when we, in type checking of a program, we added this so that it doesn't try to type check import, or just generally any procedure that is not even allocated. And I think in generation we need to do the same thing. I'm kind of surprised we didn't get an error about that actually. If we go to generate procedures, see, I would have thought that for like import, that we would not have got it. So where was this issue actually? It's here, when we're calling something. Yeah, so it's when we're calling import. Then we're adding that. Oh no, this would be when we're calling link. Sorry, I'm getting a bit confused. This is only when we call link. So the other place that references get added is, I think it's in like, this is it. It's here. This was actually another issue that I found. This is the wrong path. It should be the context path. So the path of the thing being referenced, because import is being referenced, there was no path here. There was an empty path, which means that this was actually resolving to the program, and then we're adding a reference to the program. That was the problem. So let's try that again. Okay, now we have an error. Qualified module name Yeah, okay. This, I think, is it also because I think the path, which is not letting me look at reference path. Okay, so it's length 1 and it's just import. Yeah. So this is where I think we need to sort of handle that special case. I'm not sure why this is becoming a problem, but it wasn't a problem before. But anyway, we have the case now where the path is just length 1. So when we try to get the qualified module name, you know, it's trying to get the second element, which it fails at. I do want to redo this this whole system into something much simpler, which will solve that problem. But for now, which I think will solve that problem. But for now, I'm just going to make a special case. So if length of path is 1, then we're going to say, well, that must be the globals module. So it'll be like that, globals, if I can spell it. So it would be this, the core lib globals module. And then when we get back up here, because this was assuming that it would just use the rest of the path, but in the case where there's only one element in the path, we actually want to use that element. So I guess you could say that if the length is 1, then we just want to concatenate so that this is the module name, so we just want to go dot path 0, basically. Is that right? No, we want to get rid of that bracket. Yeah, I think hopefully that will solve that problem and reveal another problem. Yes, so this is what I was expecting earlier. So this is also the procedure null issue. This time it's when we get to generation. Before it was when we were in type checking, but it's the same thing, you know. It's the procedure is, I think we have the qualified name. Yeah, so this is the import procedure, which does not actually exist, and that's totally fine. So if procedure is nil, I think we're in a loop, so we would continue. Yes, we're in a loop. We're looping through the references. So then it will just skip for import. Now it's running the health check. Let's see how she goes. Exit code 0. Let's try the other programs. That looks good. It's the playground. Output looks right. And the OpenGL example is showing pretty triangles. Great. So that's the bug solved. Basically, that's what the issue was. So we can get rid of this. My last point is move stuff to AST, but there's actually another point I want to take care of first, which is the context currently just has a path here and it has its own identifiers, but a scope is like an identifier container. And I want there to be only one identifier container. So I think I just want to do this to handle the current scope. So that can get rid of this. Out of order identifiers, I'm going to leave this here for now. I'm going to remove it eventually, so I don't really care where it is. I don't like this, and I kind of realized that it's just not needed at all. We might even remove it at the end of this session if we have a bit of extra time. But so now we have in the context, type checking context, and also in the generation context, I want to do the same thing, like so. So yeah, now we have a scope. So this copy context, what I'm actually going to do is rename that to start anonymous scope. And I'm going to be more explicit and say this is the parent context. And that's the context. We can simplify these loops. So the parent context, no, we're going from the parent context, and you can actually just do this, key value, and then I just go value, and make it even just one liner, like so. So we're copying. Is there anything else we need to copy? I don't even know if we need to copy that down. Is that necessary? We'll do it anyway. Like I said, we're going to get rid of it. So we're going to do that. And then we're going to say context.scope equals a new scope. So this is our anonymous scope that we're adding to the context. We're going to keep the same path. The path is the same because it's anonymous. It doesn't introduce any new elements to the path. That's kind of what that means, I guess. And is there anything else we want to add to the scope? I won't bother adding the statements. We don't need to add references. Maybe on the way back up. But actually references, I'm going to only keep on named scopes for now. We'll see if that makes sense. So, but we do want to copy the identifiers down. Anonymous scopes should have access to all the identifiers of the parent scope. And it doesn't need children, doesn't need typeject. But this path here, we definitely do need this now. This is important. So it's just these identifiers, basically. So we take them from the parent context and assign them to our new context. We have to do dot scope. There we go. And we return our new scope. So this is how we start an anonymous scope. And the reason I kind of renamed it is because I also want to have a matching end. We need to pass in the context we're ending as well. We don't need to return anything. So in this case, it's a matter of cleanup, basically. I don't think there's anything we want to, if I go to context, is there anything? I think the next index we do want to pass back up, and that's it. Out of order identifiers? No, I don't think that's necessary. Yeah, no, it's definitely not necessary. You don't want to move identifiers up. I'm getting lost. Where the hell was I? Context. Oh yeah, I think I just need to scroll down. So the only thing that needs to go back up, I decided, was the next index. Like if we go to start anonymous, we look at where we use that, and then down the bottom, see we always have this, which is copying the next index back up. So we want to keep that. So we're going from whoops, I think this is the wrong place. it's down here. Damn it. So we want to go to the parent context from this context. And then we want to delete the out-of-order identifiers, the identifiers, and the scope itself. So we delete context, out-of-order identifiers. We delete the scope identifiers. And then we want to free the scope. And we allocate it up here and then we free it because we don't need it anymore. There, so now we have a matching start and end. So then down here, instead of just doing this, we call end. And we pass in the context and the for context, like so. And then there's two other places where we start an anonymous scope. This one is kind of used for, it's like, I think the only reason we have it is to handle generic parameters when we do a procedure call. I don't think it's actually needed down here. I think it's more to do with this part up here. Like so. And while we're here, the problem here is that we need to, the identifiers are part of the scope now, they're not directly in there. Okay, so that's call basic for. Now this one here, we also want to just do end anonymous scope. Oops, scope context, there we go. Okay, so that's our start and end sorted. There's going to be a lot of places where we just need to add .scope, but I'm not going to do a copy and a find and replace. I'm going to look at them individually because I think there's going to be some cases where we need to do something a bit different. But so far, all of this stuff makes sense. Yeah, I think that's all fine. So now we're going to do the good old, oh, there's one in here, and I think this one is fine just to do this with. So the reason that we would need to do this, instead of just grabbing the scope, we could just use this, but I'm going to do this so that we get the name, so we're not looking at an anonymous scope, we're looking at the named scope that's actually persistent in the tree. And we always put the reference on that. That's how we're going to handle this for now. Any errors? We've got some errors up here. So I think that's fine like that. What else we got here? So this, we need to actually add the scope in instead of the path. And because the path we were adding is this path, and we've already got the scope for that path, we just go like that. Yeah, here we need to add, it's the same kind of thing. So reference path, see, we've already got the scope from it. So we put that in there. That's the same. That takes care of that. Okay, what else we got here? We've got to have some more errors. So here we're resolving types, and we want to get the module for the current scope, so that should work. Here in assignment, this is where it's a declaration. So this is, yeah, this is where you want to add to the current scope's identifiers. That makes total sense. Procedure definition also makes sense. Yeah, this needs to be a path because it could be, in this case, it's the same path as the current scope, but it could be a different one for some references. But all this makes sense. We don't get that anywhere before? I guess not. Okay. That's fine. So we'll look up here. This is another one where we want the scope. So we've just, I guess we've just type checked the program which loads the module. So we don't have it anywhere yet, so we will get it. The scope, that is. Program path. Right? Yeah, that should do. Okay. I think I saw an error in here, which is basically the same thing. I want to get the scope program path. Like so. This is the proc path, which we already have the scope from. And this here is because we used to have like two separate things that represented a procedure. You know, there used to be the procedure, and then there was the, yeah, because the current context had its own identifiers, but now it's actually using the scope as, you know, it's putting its identifiers directly in here, so there's no need for this. That interaction doesn't exist anymore. That needs to be scope now. This hopefully we'll get rid of soon. The hackiness at least. What do we have here? So, okay, we've just loaded a module. Yeah, there's two places that we get this module for this current scope, and I think I was delaying that because of the way that it was set up before, but now that we're dealing with just pointers, I think it should be fine. I think we can move it to the top. And actually, no, type check statements. If we want the module, we need to make sure that we just get the top. Yeah, I wonder if that was an error that I introduced at some point. We need to get just the first two elements of the path, because statements could be, you know, nested deep into nested procedures and nested anonymous scopes. Well, anonymous scopes don't add to the path, but there could be nested procedures, and this would not actually be the module if you use the whole path. This here, this is adding a type to the scope. So I might just get rid of that, and it means we don't need this anymore because we declared it at the front. And the current scope, which has just been loaded, so that means we need to do this. With the, I guess it's the context program. There we go. That takes care of that. We'll close a few of these. Try this again. Okay, this is our program kernels program. So references, reference, which is actually reference path, and we already have the procedure for that. That's all that was in there. Next, JSON. This is similar to what we saw before. We have something up here as well. Okay. And here, compound literal. Again, the qualified name for the current scope, because we want to create our static var name Okay, I think that's fine just through that. Pretty sure this is also like a static file path creation thing. That should be fine. Oh, looks like I've already taken care of that. This is also to get a qualified name. We don't need to put this on, you know, a path is already a slice. Do we do that anywhere else? Yeah, we do that in a few places. So this here, we're type checking a module. Actually, this is also another place where, you know, we had the main procedure, which is actually just context.scope anyway. So first of all, we don't need to get it. This would just be like this. And then secondly, because instead of putting identifiers here, we now put them here directly, we don't need this line at all. So I'm actually going to open this file because it needs a bit more attention. So then that would be just context.scope. And then the question becomes, what's the value in having this procedure at all? So it's used in two places. I think we can just replace it with this. Yeah, like that. I think that's fine. And then there's one other place here. Like that. So then, where was it? Module. This file is not needed. Excellent. I like removing things. So let's close a bunch of these and try to run again and see where our errors are. Not many left. It's just, oh, it's all to do with returns. Okay, I think that's fine to be just context.scope. Ah, that's right, I was searching for these. So this one we can remove. That is a dynamic string, so that one. And this one we can remove. So I was getting like the current scope. Wait a minute. This is the current scope. Is there anywhere else we do? There's a few places we do that. That's pointless because that's always going to resolve. Oh, is it pointless? No, I don't think it is pointless, because if we are in an anonymous scope and we want to get the current named scope, this is getting the named scope. So I don't think that I should replace those. I don't think I should just say, hey, we can just reduce this to context.scope. Let's not do that. But that seems to have solved that. So then we can go to this file, and it's also just the same kind of check. Double free detected. Let's have a look here. I'm guessing it's my, yeah, I thought it would be this. Out of order identifiers. Maybe it was never allocated. Do we need to copy them down? I did copy them down before. So if we go to context, out of order identifiers, well, length 11. That looks like garbage. I don't trust this debugger to be accurate, but that looked like garbage. So I don't know if... What happens if I remove that? Because I'm going to remove out of order identifiers anyway. Oh, this is the... Sometimes it just randomly does this. Hasn't even got to my code yet. Okay, that seems happy. So let's just ignore the deletion of out of order identifiers for now, because, I mean, it's not... We don't need to even pass them in. I mean, we do right now, but we're going to get rid of them. So let's not worry about it. But let's... At this point, I just want to check that everything is happy. Okay, that's happy. Check the health check. Before we move on to the next step, which would be to move stuff to AST. Might even do a whip commit here, just to be a bit safe. Let's do that while it's trying to do this. Okay. Commit. The whip. Okay, Xcode 0. We're all happy. Okay, so now the next thing, which should round out this refactor, is that I want to move, I think it's like type checking utils. Well, I know actually one of the big things is this get identifier node, which calls this other procedure is visible in nested proc. So I want to move this. This can now be moved into AST. I want to give AST a lot more responsibility. So init root, so this is scope stuff, qualified name, this is scope stuff, make node, print node, this is import statement, to node. I'm just going to chuck it down the bottom. Get identifier node. We have a bit of time. I'm gonna rename this to get declaration. I think that's nicer. So we don't need, we know we're in AST, so we don't need to prefix these things. And also, part of the reason for me doing this is because we don't need a context actually. We need a root scope and a current scope. So we don't need AST here. So anywhere that we have context.program, that becomes root. Okay. And anywhere we have context.scope, that's just scope. This one I didn't even put into the scope. So let's get rid of this out of order identifiers. I'll let you know when we get to fixing the errors that causes. I'll let you know. Well, actually, yeah, we better just take that out of here to make sure we do clean that up. Yeah, so when we get errors because this doesn't exist, then I'll mention a bit more about that. So we still want to do the current scope because it might be a anonymous scope, and then we want to loop through the named scopes from the current one and then move up to the root until we find our declaration. So this is the root. And oh, I can hear my fans whirring up. Yeah, one of these windows is still open. Causes my laptop to work a bit harder than I wanted it to. So let's see how we can resolve this. This says identify a node. I guess it's a declaration, right? I think that's what I meant by that naming before. Coerce type. We might end up needing to move quite a lot of stuff into AST. Coerce type in particular, I'm not a fan of. Like, that feels like a type checking thing. So moving that into here is kind of not my favorite, but it's fine. So let's say root scope and scope. Yeah, so coerce type we need to deal with, and then this would be root, root current. Okay. I think current. Oh, wait a minute. That's not actually even used. That's not used. And root is only used to get these identifiers. It's just dealing with the declaration itself. Okay. So we can cut that out. All right, so it's just this coerce type that's a problem now. And obviously, you know, we renamed to get declaration, so that's going to cause a bunch of errors. Oh, we don't need to do this anymore because that doesn't exist out of order identifiers. Nice simplification there. Okay. So are we at the point where we just try to run it and then fix all the errors? I mean, coerce type. Now let's try to get this sorted. So this coerce type is in types, I think. I wonder if this is going to cause a sort of a cascading, you know, all these other sort of type things. If they are just, if the idea is just like given a certain AST, you know, something like, can you get me, assuming that that AST has a type, can you give me the name of the type? I think that I guess my point is, I think this AST package conceptually can be type aware. It just doesn't do the checking itself, but it can be type aware. And I think that's a separation that I made before. So like in here, I think we have, yeah, we have all these types. So I kind of want to unify those. I think in the end, I'm basically going to move this file. We'll see. We'll see about this file. But this, no. Which file? This file, I think we might end up just moving everything. Like coerce type, I'm not sure about, but we need that one. Type name, type file name, upgrade types, resolve types. I think it's, let's stop talking about it and just do it. Let's just do it. So now it wants placeholder as well. It wants to be able to determine if something is a placeholder. I think we can just replace AST dot with nothing. That fixes a lot of errors. Oh no, a lot of them came back. I don't know what this problem would be. Maybe it's because of this. So upgrade types. So what do we get from the context? We get the program. So I'm just going to say root. Like so. Does that solve this? Like, why is that an issue even? Why is that an issue? Oh, maybe it's because of these errors up here. I mean, I don't think they should affect it. And a lot of this is complaining about new type node. So here we get the program, we get the scope. So again, let's do the old root scope. And that, because we're recursing, we need to pass those parameters down. So context.scope is just scope. So root scope is what we recurse with. Very nice. This is get declaration. Whoops. So now I would call that a declaration. I feel like that's a clearer distinction. So this would be also root scope, I imagine. Okay, that seems happy. New type node is still unhappy. Ah, it's because this is called node. That's what it is. Oh, that rename did not work. Rename code occurrences. Yeah, see, it renamed this as well. That was the issue. So say current node. We have an import of source. Just double check that we need all these imports. Now it's just is placeholder, which is in type checking. I think there's a placeholders file. Yeah. So let's just take is placeholders, which I guess was the only one that had strings. And I think in here there's a bunch of is this, is that. Yeah, is slice, is array, is type. Let's put it in here. Take that away. Seems to be happy with strings. So we can take strings out, and this becomes ast.as placeholder. Looks like it's also used down below as placeholder. There. Okay, yeah, we're moving a lot of stuff. But this file seems happy now. So that should be good. So then this file is empty and we can remove it. This is what we are doing. So let's see what happens when we try to run it. We should get a whole lot of errors. Let's do playground instead. So numerical types. We'll call ast.numerical types. And this is, let's do this in a certain directory. So if we go Bangalang source type checking. Let's do that. Oh, and this is tests. Okay, I'll just manually do it in here. I don't think it's going to be many. Was that even a place to do it? No. We need to find numerical types. We also have numerical types here. We need to import AST instead of type checking. Yeah, that simplifies it. There's still one place. Here we go. Okay. That solves that. There's probably a bunch more like this. Yeah. So if I do replace with AST dot, and we do this in the type checking folder as well. I don't know if there'll be any in generation. It's possible. Type name. I guess there's going to be a lot of adding AST dot to things. What else we got up here? CoS type becomes AST.CoS type. Do we have many changes? I'm curious if we have many changes in generation. Looks like none so far. I guess I scoped a lot of them to type checking. So this will be context.root. No, that should be it. Why is it? Has no field root. Oh, it's program. Yeah, I'm not sure if I should be calling them root in the AST folder. Maybe I should call them program. I kind of switched up the naming a bit there. Okay, we've got a couple more down here. Great. Let's try, see what else we got here. So this must be generation, yeah, because it's referring to type checking explicitly. So let's not refer to type checking. That's kind of one of the things that I wanted to solve with this. I don't like that type checking, or that generation refers to type checking. I feel like all of these, so the way I've got it split up is, you know, there's like generation, loading, parsing, tokenization, type checking. These are like processes. And then tokens, source, AST, they are like the data. And processes can rely on data, but they should not really rely on each other so much. There are some places where it makes sense, but this kind of stuff, not really. Yeah, I think that's much nicer. Maybe it seems silly that I do all this refactoring. I've kind of avoided it mostly in this series, but to me this is like, oh, this is so much. Feels like it just feels cleaner, it feels nicer. It's not perfect. I don't really, like I said before, I don't really like having CoS type in AST, but you know, I could potentially rename that and then would make me happy. We're in generation again. Yeah, let's get rid of this. Is t.type name. Get swizzle index. Okay, let's not try to do everything at once. So here's a get identify node. So that's actually a get declaration now. And the reason I don't want to do just to find and replace with those is because I would like also this to be called declaration path. I think that's clearer. And now this hackiness we don't need, because we can do context.program, context.scope, like this, and we get rid of that. And that's what I felt was hacky about it, you know, that it's doing this type checking stuff, which is not actually type checking. It's getting the declaration. So that feels nicer to me now. Great. What else have we got here? Upgrade types, that's an AST thing. Was it just? Yeah, just the program is required. I've got some more upgrade types. Program. So that should be happy now. Hopefully we don't have too many errors to get through. No, you took away too many brackets. So this is the declaration path. No, that one I should not have changed. It's just that one. So now we need to put the program in. And the program and the scope. Okay. Resolve types needs the program. Oh, okay. This one needs the scope as well. I was thinking of upgrade types. That's the one I've been doing a lot. That one's just fine. Identify a path. That's what I renamed to declaration path. There we go. Yeah, I like this. I like this. This is some extra clarity that I like. We'll get the declaration. We'll call this the declaration and the declaration path. So that's the declaration. We need to do AST dot. And are we happy? No, we need the program and the scope to be extracted from there. Identify a node is actually the declaration. Yeah, so that's so much clearer. We're taking the information from the declaration and putting it on the current node. This is AST integer types. And again, getting the declaration here. All right, we need the program and scope. Cool. And our statements. Okay. This is where we used out of order identifiers. The sole purpose of it was, in my head, the idea was, we need to be able to refer to procedures before they're declared, because otherwise, you know, how does one procedure refer to another? or, you know, there could be two procedures that recurse. You know, one calls, A calls B, then B calls A, and they recurse in that way. And then I realized when A calls B, that's not in the same scope. That's in the procedure itself. You know, there's the scope where the procedures are declared, and then there's the scope that is the body of the procedure. So you never need to refer to a procedure before it's declared in the same scope where the procedure is declared. It's always a nested scope. So you don't, this is just, I don't know if that makes sense, but essentially what it means is you don't need this at all. You don't need that at all. So I just check it out. I'm pretty sure that, well, fingers crossed, it doesn't cause any issues. I'm pretty sure I need to put the scope into this one too. There we go. Not AST, context scope. Right. Our scroll bar is still pretty big, pretty small. It means we still have a lot of errors. AST, let's see if we can get rid of type checking out of here. Just a couple of times we refer to types. Nice and simple. Here we need to get the declaration. So we need the program and the scope. And this is the declaration. Like so. That's that sorted. Yeah, this is in generation, so let's get rid of this type checking reference. Very nice. Ah, was that it? Oh, I thought there was more somehow. Convert. Hopefully this is very similar, it's just that we're referring to the type lists. Yep. Now we have a nice big scroll bar. Okay, we're getting there. We're getting somewhere. Let's not import that. Fantastic. Great. Happy. Okay, I think this is the last place. Yeah, this is the last place. This is where we really cross our fingers that, you know, after a whole session, we don't need this Boolean anymore. That was to do with the out of order identifiers. That we have not screwed everything up. Okay, moment of truth. Hey, the playground ran. OpenGL is running. And the health check will succeed. Will succeed. Hey, it succeeded. Fantastic. So that rounds out our refactor. Now scopes are like a single solid concept. We don't have like, we removed 3 structs. It was like program, module, procedure. They are all just scopes now. And we also have this idea of an anonymous scope. Generation, we also have this copy context here. Just wondering if we should, I think that's fine, we'll leave that. I was wondering if we should rename that to like start anonymous scope also. Oh, what? It's never actually used. Huh. what did it do? It copied the stack variable offsets. I'm going to put a note here because maybe it's a problem that it's never used. I don't know. Or maybe it's something we can just get rid of, which would be nice. Okay, so I'm happy with the refactor. Next session, I want to get on to actually improving the language again. Like this was all, we didn't fix any bugs, we didn't add any new features. Haven't done that for a couple of sessions now. But in our playground, we do have down here this kind of thing. A recursive struct. And I think the refactoring we've done is going to help us to implement a fix for this, allow this. Essentially what I want to do is defer type resolution. And I think that's going to end up simplifying things quite a bit, actually. And you know how I love simplifying things. So I'm looking forward to that in the next session. But for today, I think that's enough. Thanks for stopping by. Have a good one. Ciao for now.